Okay, for this question, right, I'm going to continue for this part, okay? Because we just finished for this fx function defined by fx equals cosine square root x, we did find the middle point Riemann sum for the A, and then we did find the trapezoid is overestimated. Now we gotta go to the last part is the C here, okay? Now, when you do the C, you will see that they said write fx, write the integration from 1 to 3, right? Right, like this one, 1 to 3, and the fx dx as the limit of the right Riemann sum with n subintervals of each length. Okay, so when you do this kind of question, we go this way. We said we put like we still general sketch first. Okay, this one as what we just drew it and just redrew it. Okay, this is the 1. This is what 3. Okay, the graph generates like this, right? We don't care exactly what it looks like. We just for the illustrative purpose to end here, right? Now we're gonna make up the Riemann sum. What's mean of Riemann sum? Means we try to use as many as rectangle possible to add all those area of the small rectangles and add together. So for example, here we cut this one, like this one, like this one, like this one, okay? We'll cut like this, right? So now, suppose we cut for the n sub small rectangles there. So we're making a, and then they said what? Riemann sum to find the length, right? Find the area, approximate the area, okay? So what we can do is this. They told you that's right Riemann sum. Be careful. How do you get a right Riemann sum? You go like this. You see, you cut like this. So first thing first, we need to determine the base. You see, like this kind of area. Like this is the right one. So we pick up the right one as the height. The right one as the height, okay? Right one as the height. So from, oh wait a minute, map out of here. So actually, if you say right one as the estimation, so you should pick up what for this rectangle, you pick up the right one as the height. For this rectangle here, you gotta use this, right? This as the height, and then this is the height, and then this is the height, and then this is the height. Okay, like this, huh? So what we're gonna do is this. You think about that. Total from here to here is 3 minus 1. That's 2 units. But I'm going to cut into n intervals. So end up with each of the base will be 2 over n. No problem, right? So this is 2 over n. This one also 2 over n, 2 over n, like this. So when you have a rectangle, be careful here. This coordinate here, x coordinate is what? Is 1 plus 2 over n, right? But we can put like this. We can say this one is this one times by 1, because from 1 here, 1 times 2 over n to the add 2 over n here. But this coordinate will be what? 1 plus what? 2 over n, right? But you have how many 2 over n? 1, 2 here. So you get time by 2. Imagine this one will be what? Will be 1 plus 2 over n times by 3, because you have 3 2 over n to reach to this point, right? So in general, for example, this is the I place. So that means the x coordinate here, x should be what? 1 plus 2 over n times the I, right? So this is the x coordinate. So if you want to find the function value of the height, for example, like this height, how high this height should be? Should be the f 1 plus 2 over n times 1, because the x coordinate is what? 1 over 1 plus 2 over n times 1. And then you use fx of f of that means this height. So in general, any height, we're talking about the ith, okay? For example, this is the ith rectangle, okay? So when we do the ith rectangle, you go by what? You go f1 plus 2 over n times I. Because from 1 there, you're going to add I of the 2 over n, that's intervals, to reach to the xi here. This is the xi, right? And then this is the function. And then we're going to time by what? Time by this is the height, and times the base. Base always what? N, oh no. Base always equals what? Because total interval is 2 and cut by the n past intervals. So this is the base here. Again, this is the base. Got that? And this is the area of the ith rectangle. And we're going to add them. We're going to add the rectangle from from 1 to n, because I cut total is n. So that means that this is the sum. This sum means what? You got to add all of this, many of the small rectangles, okay? Right now, I just drew 5 there just for the illustrative purposes, but actually they have an infinitive many, you cut it off, right? And when they say Riemann sum, we got to put the limits at n approach infinitive. Means after I cut n units and then make the n go to infinity, means I chop it into very, very tiny, skinny rectangles, and add all those. That will be exactly matched with the area underneath of the curve. Actually, that's the integration from 1 to 3fx dx. That one equals this one. Okay, so that's why write this one as the limit of Riemann sum of those. That's what we're doing here right now. But right now, you see, if it's a limited number, for example, you have 5 rectangles here. You see, this rectangle's area add together is underestimated of the area underneath of the curve, because here not counted. Here not counted. You see the small gap there, not counted, right? So that means we just pick up the bottom one here like this. So that's called underestimated, right? So when we have this, we're gonna have this one here. We go by limits and go to infinitive, right? Right? And then we have sigma I equals 1 to n, and f, this one, we got to go by what? Cos, because f is cosine, right? Cosine, and then what? This is 1 plus 2 over n times I. And then time by 2 over n, like this. So this is called right Riemann sum. Why is it right? Because I'm picking up not the f1. I pick up the f1 beginning and f1 plus 2 over n times 1, and then 2 over n times 2, 2 over n times 3, like that. So go by this one, means I always pick up the right one. See that? So that's called the Riemann sum. So this is the answer for this one. Okay, this is the answer. So actually, Riemann sum is very important for the integration. That's the beginning of the integration, and we need to know how to set it up with. Okay, if you have any questions, please let me know. Thank you. Bye bye.